Alright, hello class. I had a question about number 2 from the review. First thing, this question should only be talking about deer. I had a little typo there where raccoon somehow made its way in. It's all about deer. That's all we really need to worry about here. So it's possible to solve a question like this using our expected value formulas, but it's actually a little simpler if we just set up a proportion, and it's kind of easier to set up that way. So we're given that we're trying to find the entire population. They caught 200 deer and tagged them. 65 were later caught and 25 were tagged. Okay, so this is kind of giving us a ratio of population to the amount tagged. So this is going to allow us to get an estimate for how large the deer population is. So the 65 were caught and 25 were tagged. And we're told here that initially 200 were tagged. That allows us to solve for what could be the population here. So this is just going to be an estimate, and from here we can cross multiply. If you wanted to set this up the opposite way, you could have 25 tagged over 65, 200 over x. It'll give you the exact same answer, so don't worry too much about that. Just make sure that, okay, we've got the two populations here, we got the two tagged numbers here. So if I cross multiply, or really all I need to do is multiply this 200 up here. We end up getting an answer of 520. Okay, so we're estimating that the deer population in that area is about 520 deer. All right, I had a question about number 7b. I'm going to go through 7a as well, just to go through it all. We're told that there are 4 cats and 6 dogs. 4 of these animals are chosen at random. What was the probability that we have 2 dogs? Okay, so if we have 6 of them, and we're saying we have exactly 2, we have 6 C2 times 4 C. Well, if 2 are dogs, that means that 2 are going to have to be cats. And this is a total of 10 animals, and we're choosing 4. Now, I think in my solution, I'm going to have these flip-flopped, but I think we get to the correct answer there. So this is going to end up equaling 15 times 6 over 210, which is our 42.9%. Okay, so that was A. B, the expected value for something that is a hypergeometric problem like this. So this is a hypergeometric problem because the events are dependent on each other. So once you select one animal, the probabilities are going to change for selecting the remaining cats and dogs. So we're going to use our formula. Okay, so this is the expected value formula for something that is a hypergeometric distribution. So, all right, so for B, we're finding how many dogs can be expected. And there was a mistake there. I think I calculate the expected number of cats. So the expected value of dogs, we're going to have 6 times 4 over 10. So how many total? We're choosing 4. There are 6 dogs in total. So we've got 2.4 dogs expected. I think I accidentally calculated the expected number of cats in our solution sheet. Hopefully that clears that up.